Okay, today is Unit 11, Lesson 6. It's about graphing exponential functions, and this first page of it is just a big old review of those numbers cubed, like 3 to the 4th, which is 3 times 3 times 3 times 3, which if you split it up isn't too bad. 9 times 9, it's 81. Anyway, we need you to know those because there's going to be a lot of working in your head with numbers like this, because calculators will not be allowed for graphing these. It'd be super easy to just type it in the calculator and hit enter and it would graph it. But we need you to be able to do this without a calculator. All right, so I'll get to that graphing stuff in just a moment. At first here, I want to give you a few practice problems that are kind of like what you've learned up to this point. All right, these 4 questions. Let's see how you would do on these 4 questions. I'll pause for a second. Okay, so here are the answers for this one. I would square both sides here. Does squaring both sides make you do absolute value? No, it's square rooting both sides that would make you do absolute value. This does not. This just is something dangerous. Did you kind of sense danger? Kind of like when you walk down the trail and you hear the big, like, scary noise in the woods. It's like, oh my gosh, is that a bear? Actually, there are bears in Minnesota that are the black bears, and they're pretty tough. I mean, they got big teeth and they're strong and stuff, but the ones you really have to worry about, go ahead, are the grizzlies. We don't have them in Minnesota, but then really have to worry about the polar bears, because they're the only bear that will actually stalk humans. They will actually like hunt you like prey. They'll sneak up on you, all that stuff. The grizzlies are very dangerous just because if you bumble across one and you like surprise it, it might attack you just because it gets spooked. But the polar bears are the ones you really have to watch out for. So I know there's a lot of people feeling really bad for the polar bears right now because there's less, less ice and stuff. But the reality is the polar bears just want to eat you. So I know they're majestic and it's all, yes, true. But I'm just saying they are a very dangerous bear. Okay, so on number 1, once we have sensed danger, that doesn't mean I like stop doing the problem. I still finish the problem and get an answer. I'm going to subtract 2x from both sides, and I'll get -7 equals x plus 8, and then I subtract 8 from both sides, and I get -15. And then I need to check this, though, to make sure it actually works. So I put this back up in here, and in both cases, it makes a negative underneath the square root. Therefore, it does not work. Therefore, that is an extraneous answer. Okay, how many of you had that one right? Good. On to the next one. This one, I take the third root of 27, because the roots go on the bottom, just like in plants. So that's the root. It's the third root of 27, which is 3, and then that's a normal power. 3 to the power of 2 gives me 9. Raise your hand if you had 9 for that one. Good. On to the next one. Get the clump alone. That's the clump. And you'd add 3 to both sides, and this would become 125. Do you think I just picked that number randomly? No, because 125 happens to be that special number that can be what to the what? 5 to the third. Why is that good? Because now that base and this base are the same, so that means 2x has to equal 3. And if 2x equals 3, x equals 3 halves, or 1 1/2. Raise your hand if you had that one right. Many people look like they're going to ace this one, and it gets down to the last one. And now I'm going to go, I could either multiply by 4 to the x on both sides, or probably smarter, write this as 4 to the 3 minus x is equal to, do you think I just picked the 16 at random? No, 16 is actually 4 squared. Now that the bases are the same, that has to equal that. 3 minus x has to equal 2. And 3 minus what equals 2? X must be 1. Now, final answer on that one, x equals 1. But did you go back and check it and see if it actually worked? It doesn't work, so it's extraneous. Bet a lot of you didn't even check it. Okay, I'm lying to you right now. But did you check it? So you should check it just to be, oh, some of you did. That's good. Okay, so if you didn't check it, you could have got that one wrong. You get what I'm trying to say? Check your answers, make sure they actually work, because it seems like it's 1, but until you actually go back and put it in, you don't know for sure if it works. I'm going to put it in right here. Now, granted, this isn't the kind that usually fails. The kind with square roots on both sides is the kind you got to watch out for. But this one does work because 4 to the third over 4 is like 4 to the second, and 4 to the second is 16, so it actually works. All right, who had the coveted 4 out of 4? All right, good. Now that your confidence is high, I can destroy it because this graphing is tough stuff. All right, let me see if you remember some real basic stuff. Do you remember when we had y equals x squared and then we like did this and moved it over, like let's change that to a 3. That means it moves 3 to the right. Does that ring a bell? Okay, what if you put like a plus 7 out there? What does that do to it? It goes up 7. Okay, now all it is today is you have a new parent function. Your new parent function is that, 2 to the x. You don't know what it looks like yet. But if I have this function and I then do this to it, let's make it a 3 again. Where do you think I just moved it? To the right 3. And then I do this to it. Where do you think I just moved it? Up 7. Okay, but now we just got to know what it looks like. What is this new parent function or mother function, if you will? It is this one. That is exponential growth. Does it look kind of like exponential growth? Well, that's what y equals 2 to the x looks like. Now, what if it had been 3 to the x? Do you think it's going to go faster? Yes. Yeah. Because instead of going 2 times 2 times 2 times 2, it's going 3 times 3 times 3 times 3. That's even faster. So when you go through this spot right here, it just takes a sharper turn. But do you notice it goes through 1 again? It'll keep doing that. If I graphed like 4 to the x, it'd be even steeper. So what's happening there? Why is it always going through 0? Because at that moment, x is 0. Think about it. If x is 0, you get how we have a 0 here, 0 here. Do you get how the answer always reverts back to anything to the 0 is 1, and that's why it always goes through this spot. Now, can I force it to move up? Yeah, I can like slap a plus 7 out here, and the whole thing has to move up 7. But until I do that, it's going to always, the parent one is going to always go through 0. Just the bigger the base is, the tighter this turn is. One more thing you should know, there's a dotted line across the bottom. What are those called? Asymptotes. It gets closer and closer to that, but it'll never touch it. So on the left side is where it gets closer and closer to 0. That's where like x is like -2. Okay? Do you get how if x is like -2, it's 2 squared is 4, and the negative makes it 1/4? And then the next one would be like 2 to the third, which would be 8, and then it's 1/8. And it's getting closer and closer to 0 as I move this way. Because this, you have a negative exponent going on, which makes it a smaller and smaller fraction. Okay, that's exponential growth. Does everything grow over time? No. No, some things shrink over time, like sadly our moose population lately. Our moose population is not doing this kind of a thing. That would be exponential growth. It's doing this kind of a thing, which is called exponential, what do you think? Decay. All right. And that's going to be a very similar y equals something to a power of x, but what do you think's different? Nope, not negative. It's a fraction. Like instead of 2 to the x, 1/2 to the x. That's going to make it get smaller and smaller, because like if you go 1/2 times 1/2, it's 1/4. Or 1/2 times 1/2 times 1/2, it's 1/8. And it's going to get smaller and smaller. So this could be anything you want. It could be how many elephants there are in the world right now, and it's shrinking. And I think elephant populations, probably depends on the type of elephant, are one of the ones that's been shrinking over time. Our moose population is low, but there's tons of moose in other places, like in Alaska. There's zillions of moose, and there's a bunch of moose next door on these islands in Lake Superior. But in Minnesota, our population is definitely going down. So what if I wanted to take this whole graph and move it up 3? Would you please rewrite this for me, except moved up 3? And why don't I say up 3 and right 9? Up 3, right 9. See if you know where to put those things to make this equation go where I said. I'll pause for a second. And I'd like you to compare it with the person that I pair you with. Okay, so up 3 and right 9 meant this. This is the up 3 part. This is the right 9 part. You don't have to put parentheses, but if you were going to put them anywhere, that would be a good place for them. Raise your hand if you had that right. Okay, good. So now you got the basics. Now the hard part is actually getting all the dots on the graphs and seeing like, okay, how do I actually graph that? Well, I'll tell you, if I was going to actually graph this and actually get dots that I connect to make a line that kind of looks like this, except, again, up 3 and right 9, so it would look kind of like this. Where exactly are the dots? My advice to you is that the best friend on these is the XY chart. If you can make an XY chart and choose wisely what you pick for X, you can pick anything you want, so pick wisely for these numbers. Then you'll be good. Do you remember the Indiana Jones movie where in the movie he is trying to pick which glass to drink from? And the old man who's like guarding them is saying, choose wisely. Because basically, if you drink from the wrong one, you're going to die. Anyway, so this is just a movie, I know. But in this, if you choose wisely, these can be really easy. Like, give me something I should put in for X that would make it easy. 9 is an easy one. Why is 9 easy? Because it makes this equal 1. No, wait. It makes it equal 0. Sorry. 9 is good because it would make this equal 0, which anything to the 0 makes this equal what? 1, and then 1 plus 3 is 4. So 9, 4 is a point on my graph. Over 9, up 4. There's a dot like here. All right, that's just one of many points that I would need to graph, and then I just connect the dots. What's another thing? Choose wisely. 9 was a good choice. I'll give you something that wouldn't be so awesome. Do you get if I put in 0, even though 0 is one of my favorite numbers, I put in a 0, I'm going to have to do 2 to the negative 9th power. Not fun. Get what I'm saying? So don't choose 0. Choose wisely. What's something else I could put in here? 10. 10 works nice. 10 minus 9 is 1. 1/2 to the 1 is 1/2. 3 plus a half is 3.5. So I put in 10, and I get 3.5. I can graph that. Over 10 up 3.5. That's easy. So choose wisely, and your points aren't that hard. Choose just random numbers, and it can be really hard. All right. Now here's one more way you can do it, and I like this way too. Some teachers teach this as take this and simplify it down to its most simple, which would be y equals 1/2 to the x, and make the parent points for that. Once you've done that, then you just take your graph and move it 9 to the right and up 3. Do you get what I'm saying? So why is this any better? Because these are simple points to make. But at the end, I'm going to have to, please, take all my points and move them 9 to the right and up 3. So it's your choice. You either do it easy at first and then you have to do some extra steps, or you just get it all done with at once and you choose wisely what you put in. Well, let me show you how easy it would be if I wanted to just graph the parent one and then I'll move it later. I can put in anything I want for x now because anything becomes easy. If I put in 0, anything to 0 power is 1. If I put in a 1 right there, 1/2 to the 1, 1/2 to the 1 power is 1/2. If I put in a -1 here, -1 power is the flip power. So it changes from 1/2 into what? So when I put in -1, I get 2. So it's kind of easy to get those parent points if you do it that way, but you have an extra step now of now you got to graph it and then move it right 9 and up 3. Okay? Whereas if you suffer through it in the first place and just choose wisely what numbers to put in, you can get those points right off the bat and you'll never have to move it. Get what I'm saying? But it's your choice. You get to pick on that. You can either boil it down to its simple apparent function, get those points, and then move it, or choose wisely at the beginning, and then you'll have all the points you need and you just graph them directly and you don't have to move them. All right. That's the basics for this lesson, and I think you've learned everything you need to learn. Now, I'm going to go to the homework with you because the first few problems are always tough for people. This is one where I definitely want to get you started on your homework because if we work them together, it's not that bad. But if I just turned you loose on your own, you'd probably get a little frustrated. I'm going to pause for a second while I pull up that worksheet, and you do it too, please. Okay, I've got mine ready. And if you're already ahead of the rest of the class and yours is up already too, what you should be doing is making sure you get that the parent one is the black one here. The parent one is this one. And what you're trying to do is figure out if we move it from where it is now to, let's say, the red graph, do you get I'm going to have to move it down and to the right? You just have to look it up and try to figure out how far down and how far to the right. And if the parent for this red graph is y equals 2 to the x, and I decide to move it right 3 and down, down 5, your answer would be this. But it isn't right 3 and down 5. You figure out from looking at the picture what it really is. That one was actually the easy one. Let me help you with the blue one. How many of you think you already got the red one? All right, so like 5 or 6 people. That's good. You figured out how far to the right to move it, and you figured out how far down to move it. All right. Now, even if you're not done with the red one, I would suggest you get my help on the blue one. See, the blue one's tricky because you don't just move it up some amount. It goes from 1/2 to 3. Well, that's up 2.5. It goes from 1 to 4. That's up 3. It's not up 2.5. It's up 3. This one's from 2 to 6. That's up 4. It's going up different amounts each time. Yes, sir? Okay, so if this isn't just adding something each time, what are you suggesting that I do? If I don't just like add 3 to move the whole thing up. All right, so you're right. You're going to stretch this thing and put something on the outside to do that, and you're going to move it up. So my question is, how much do you think you're going to multiply it by? And how much do you think you're going to add to it? That is what makes it hard. It's not it's not like rocket science here, but you got to figure out what to multiply your function by to make it go to this and add. It isn't just multiply. It'd be awesome if it was, but you can't just like slap in a 2, because if I double 1/2, it doesn't turn into 3. If I double 1, it doesn't turn into 4. But you can multiply it and add something, and you'll have it. That's my heavy-duty hints for that problem. Okay, you have to figure out exactly how far it goes. All right, the other ones are just like that underneath that, except these are decay functions. So once again, the parent one is the black one. So this one is the main one you look at, and then you say, okay, well, how does it get from the black one to the blue one? It looks to me like they all move to the left and they all move down. That one's pretty easy. The red one in this case is the tough one, because the red one, I'll give you a hint. This one moves in, this one moves in, and this one is straight up from where it was. Do you get how it's getting horizontally squished? Do you remember how to do that with a number in the function? How do you do a horizontal squish? That's what you have to figure out. So the red one's tough. Here's the parent of it, 1/3 to the x. You just got to do something to it. Let's say a horizontal squish was like this. It's not, but then you do that. That's not a horizontal squish. All right, I'll let you figure out the rest of what to do on that red one. Okay? Now those are the tougher ones. Those are like, oh, this is impossible. And you're like most people, okay? Don't just give up on them. Try them, but It's not like you have to be master of this by tomorrow. We aren't testing till next week. All right, let's move on to these. These are more normal ones. These you just need an XY chart. And remember, you got two options. You can take the pane and just get it all done at once and find 3 or 4 points that work and then just connect the dots. Or you can find the parent function for it, which would be, in this case, what's the parent of this? Y equals 3 to the x. Good. And you could find the parent points for that, and those will be quick and easy. But then you'll have to do what to it? Check it by moving it right 2 and down 6. Okay? What I like to do, my opinion, is just take the pain of doing it all at once, and then you just have to graph your points. But I got to choose wisely. Tell me a number that I could stick in. 2 is a good choice. If I stick in a 2, then 2 minus 2 makes this part 0. Anything to the 0 is 1. 1 minus 6 is negative 5. I know 2 comma negative 5 is my final point on the graph. I don't have to move it anywhere. It's just done. 2 comma negative 1, 2, 3, 4, 5. But just from one point, I have no idea where the rest of the graph is. I'm going to have to do a bunch more points. Choose wisely, otherwise these will get out of control. You like just decide to slap in a 9? Great, then you got to do 3 to the 9 minus 2 is 3 to the 7th power. I have no clue what that is. So just be careful. Choose wisely on your x values. Use things like zeros and try to make the power 0, make the power 1, make the power negative 1. So think of what numbers you could put in that would make that power be negative 1. All right.
What about like,
you can use decimals. If I do this is 2.5. If I use 2.5 minus 2, that's 3 to the 1/2 power minus 6. But the problem is the square root of 3 is not nice. Okay, so if this had been a 9, that would have been a genius idea, but it's not. So probably not 2.5. Anyway, if this gets too tough, just go to the y equals 3 to the x and find the xy chart for that. Those numbers will be easy. Whoa, can't explain what's happening here. Pausing. Okay, so these next few, I'd say there's enough of those that you may skip number 6. Number 6 is probably overkill. You'll have already done 3 heavy-duty graphs there. So everybody skip number 6. Moving on, let's look at number 7 together because it's got words and sometimes that makes it scary for people. All right. Number 7, E. coli double in population every 30 minutes. Do you remember these functions where we have a start value right here? We started with 2,000 moose and it was growing by 5%, except for moose it was falling. But anyway, do you remember those exponentials we were creating? Okay, it's just like that, except it's different now because the starting value in this case is 85. So I start with 85. What else is different about this? It's doubling every 30 minutes. So what's my growth factor? Do you think I should put 1 plus 2? That would be timesing it by 3. Do you think that's what I want to do? 1 plus 1. Because then I'll be multiplying it by 2, which is doubling, right? You got to think that through? Okay. Oh, somebody's having more fun than me. All right. And then I have to figure out how to put in this whole, like, in 30 minutes. It has to do with the time. And it'll happen in 30 minutes. Because if I put in 30 now, do you get 30 divided by 30 is like putting it to the 1 power? I know that was a stretch. I told you this was not easy stuff. If it's in 30 minutes, then, oh, you know what? I'm sorry. They made it easy for you. You don't have to do it that way. My bad. It says right here, let x equals 1 represent 30 minutes. So that means x equals 1 is like a set of 30 minutes. So then this is just plain old to the power of x. And how am I supposed to know what it ends as? I'm supposed to know one more thing to be able to solve this. How do I know what it's going to be when it's done? Because it doubled. And so it started at 85. There you go. It's 170. Very good call. Now I have everything except just one x. Do you get that when you have that, you can solve for x? And I gave you away with a calculator. Graph. What? Graph both sides and see where it crosses. Good. Graph both sides, see where it crosses. Y equals 170, y equals that. And once you got them both graphed, they're going to cross. And whenever they cross, that's x. And that tells you how many 30-minute periods that it'll take for that to happen. Okay. And anyway, actually, this one's really simple because 1 plus 1 is 2. And if I'm solving this, I get the clump alone, right? 170 equals, and I divide by 85 on both sides. And the cool thing is, when you take 170 and divide it by 85, you get 2. And then you'll have 2 equals 2 to the x. And then you're like, well, what's x got to be then? X has got to be 1. Okay. All right. But you could have if you needed to. Remember, anytime you have a tough equation and a graphing calculator, all you got to do is graph both sides, see where they cross. Okay. If you weren't, then you'd have to just have really nice numbers like the one we just did there, where if it was really nice numbers, the bases would be the same. You can get the answer that way. We can fix the numbers to make that work so that you can't have a calculator, or we can make it so you can have a calculator. We're not telling you yet. I'm not telling you yet. I'm not even sure. But we'll make it do what's doable. So, all right. And then this very last one is also doable, and it's more simple because now we got a simple 16% is eliminated. Does that sound like growth or decay? Decay. So it's dropping 16%. I hope you remember how to do the start. And then if it's going to drop by 16%, it'd be like this. And it's kind of like that. But I'll let you finish it. Okay. That's all the help I have for you for today. I only had you skip a few. 1, 2, skip a few. Actually, it's 1, 2, skip 6. And then I do want you to do 7 and 9. And there is no 8, I guess. Well, there's an 8. My bad. I guess it's just sketch the graph. You can sketch them just like we were graphing those other ones. So I guess the only one I really had you skip is number 6. Kind of a longish assignment, but at least I did a bunch of it with you. All right, so if you need more help, come on up and ask. I have done with the video for today.